Hey guys, today we'll be talking about wave phenomena at home. It's a study conducted by me, Raymond Chu. Turn on the sound for the best experience possible. So, what are waves? Simply put, waves are vibrations that transfers energy from a place to another without the use of matter. Waves are separated into two different categories, transverse waves and longitudinal waves. Transverse waves are waves moving perpendicular to the direction of the energy transfer, and longitudinal waves are waves moving parallel to the direction of the energy transfer. To better understand this, you may look at the picture on the right. Now, wave phenomena number 1, reflection. In physics dictionary term, reflection is the change in direction of a wavefront at an interface between two different media so that the wavefront returns into the medium from which it originated from. To show reflection, I've chosen to use sound, a longitudinal wave, as my example. Reflection is created when the sound waves of my voice bounces off the wall of the school. This creates an echo. The louder I talk, the bigger the echo. Wave number 2, refraction. In physics dictionary terms, refraction is the change in direction of a wave passing from one medium to another caused by its change in speed. For example, waves in deep water travels faster than in shallow water. To show refraction, I'll be yelling into the pond, which then the sound of my voice will be heard on the other side. This happens because the water cools the air above its surface, and cool air slows down the sound waves near the surface, causing refraction or bending of the sound waves. Before you play the video, you may look at the picture for better understanding. Wave phenomena number 3, diffraction. The physics definition of a diffraction is defined as a bending of a wave around the corners of an obstacle or aperture into the region of geometrical shadow of the obstacle. To show this wave phenomena, I will be talking through a door with a small hole. Diffraction occurs because when my voice wave travel through the hole in the door and then the waves spread out greatly on the other side. That's why my voice can be heard relatively clear. Before we watch the video, you may look at the picture on the right, small gap and large gap.
Hello.
Wave phenomena number 4, interference or superposition. In physics dictionary terms, interference is a phenomenon in which two waves superpose to form a resultant wave of greater, lower, or the same amplitude. To show the phenomena, I will be creating constructive sound waves, longitudinal waves, with one glasses by rubbing the rims with a wet finger. This occurs because every piece of glass has a natural resonant frequency, and when two of the same one glass is rubbed at the same time, the sound wave of the second glass becomes constructive to the first one. Well, because it's the same frequency, thus making it louder. Before we start, you may look at the picture for better understanding. As you can see, one wave plus another wave equals a bigger wave. They have to be Wave phenomena number 5, Doppler wave. In physics dictionary terms, Doppler effect is an increase or decrease in the frequency of sound, light, or other waves as the source and observer move forward or away from each other. The effect causes the sudden change in pitch noticeable in a passing siren. To show this, I will run past the camera with a siren playing out of my phone. Doppler effect occurs as I run past the camera, and as I come close to the phone, the frequency of the wave changes and the sound waves become higher pitched. As I run away from it, the pitch of the sound decreases as the waves got weaker. Before we start, you may look at the picture and listen closely. Wave phenomena number 6, a standing wave. In physics dictionary terms, standing wave is a vibration of a system in which some particular point remain fixed while others between them vibrate with a maximum amplitude. To show this, I will be rubbing the rims of one glass to produce its natural resonant frequency. This occurs because as I rub my finger on the rim, my finger first sticks to the glass and then slides. This stick and slide action occurs in very short length and produces a wave of vibration inside the glass that causes the air molecules to move at the same frequency. In turn, produces Thank you for watching, and this is my bear, Lenny, waving goodbye. Also, if some of the sounds you didn't hear clearly, you can always go back and listen to them again. Thank you very much, and see you next time.